Today we are going to discuss about ROM in the module 5. What is a programmable logic devices? PLDs. PLDs are integrated circuit or ICs. They contain the array of AND gate and another array of OR gate. So what is a programmable logic device? These are the ICs or integrated circuits. They consist of AND gate and OR gate arrays. There are three types of PLDs are there, and it is classified based on the type of arrays used here. And here it has also a programmable feature, that means it can be programmable. And first one is programmable read-only memory, that is PROM. There are three types of PLDs. One is PROM, second one is programmable logic array, PAL, and third one is programmable logic array, that is PLA. So if we these are the integrated circuits that containing arrays, OR gate arrays and the AND gate arrays, and we can enter the information into these devices through some process. That process is known as programming. So the process of entering information into these devices is known as programming. Then first one is read-only memory, ROM. These memories, the name itself specified, it can perform only read operation. So we can only read, it cannot write on it. And this type of memory is non-volatile. That is, the data contained in that memory cannot be changed or cannot be modified. That means the information stored in this memory is permanent. That is, that data stored during the manufacturing time. A ROM stores such instructions that are required to start a computer. So that operation is known as bootstrap operation. So whenever we starting a computer, it load the BIOS setup. BIOS means basic input output system. So that BIOS is mm, BIOS is stored in the read-only memory, ROM. That means when it is a non-volatile memory, the data stored in that memory is permanent. So ROM is a logic device that has fixed AND array. It has fixed AND array and a programmable OR array. So we know that ROM is a combination of and OR arrays. So AND array is always fixed and OR array can be programmable. Then this is the block diagram of a ROM. Here we are using a AND array, fixed AND array and a programmable OR array. Here we provide n inputs. So this AND array produce AND gate. The input of the AND gate are not programmable because it is a fixed AND gate. So we have to generate, here it generate 2 raised to n product terms. So after the and now when we given the input to the AND gate and array, it produces the output, that is product term. It product is, if there are n input, how many product terms are there? 2 raised to n product terms are there. It uses 2 raised to n AND gates. And here we can implement these product terms by using a n by 2 raised to n decoder. So here we can replace this by a decoder. Its input is n and output is 2 raised to n. So this decoder generates n min terms. So it generates and minterms. Next is we are using a programmable or array. So the programmable input of a programmable or array is the output of the AND gate. And here we can program any number. It's a programmable array, so we can program any number of required product terms, since all the output of AND gates are applied to the input to each OR gate. So here the all output of that AND, that is all product terms, are given to the input of the programmable OR array. So here the output of the prom will be the form of sum of minterms. So there are m outputs are the, it is in the form of sum of minterms. So here minterms are the product from the AND gate, and OR gate perform the sum operation on that minterms. So this is the output sum of minterms. Here the implementation of the Boolean function using prom. Prom is a programmable read-only memory. Here we are giving two equation A and B. Two functions are there, and it uses three variables x, y, z, and another function B that uses x, y, z. And here we require a, here we use a 3567, and here it is a 3567. So using 3 input, how many outputs are there? 2 raised to n, that is equal to n is the 3 input, 2 raised to 3, that is 8 outputs. So here we use, instead of AND gate, we are using a 3 input 8 output decoder. And there are two functions are there, so we are using two programmable OR gate for producing these two functions. So there are two functions, so we are using two programmable OR gate. And this is the 3 to 8 decoder. This is the 3 to 8. Here we are using three inputs x, y, z, x, y, z, and the output of the 3 to 8 decoder is the minterms. So M0, how many inputs are outputs are there? 8 output, M0, M1 up to M7. For two functions are here. For the two functions, we are using two OR gates. Two functions are there. So for that two functions, we are using, for A, another function is B. For that we are using two OR gates. Here two OR gates are used. So this OR gate can access all these 8 terms. M0 to M7, there are 8 terms are there. These all 8 minterms can be accessible by these two uh, OR gate. But we are only required the minterms that are programmed in order to produce the respective Boolean function. For example, for first function it only requires 5 6 7, 5 6 7, and second function requires the Boolean function 3 5 6 7, minterms 3 5 6 7. So here that is programmed. Here for A we are only using 5 6 7. This cross symbol indicate the programmable connection. So first A function containing the minterms M 5 6 7, and for B it containing, what are the function? M7, M6, M5, and also M3. So M3, these are the connections. So it containing the function 3, 5, 6 and 7. So this is the diagram of a implementation of a PROM. And there are mainly three different applications that are used by ROM. First one is it is non-volatile memory and it can store the data permanently. The main applications are they are used in embedded system or any system where the programming does not need to change. So main application it is used in embedded system, and it's also used some appliances, toys, automobiles, etc. Here uses chips to maintain information when the power is shut off. After the power is shut off, the information will be retained in the ROM memory. And the last point, it is mainly used in calculators, peripheral devices such as laser printers which store the phones. So mainly it is used in calculators and the printers. Next two topics are different types of ROM. First one is masked ROM. It's a very first ROM were hardwired devices that containing pre-programmed set of instruction and data. That means already നമ്മുടെ program ചെയ്ത ഡേറ്റാസും ഇൻസ്ട്രക്ഷനും ആയിരിക്കും മാസ്ക്ഡ് റോമിൽ ഉണ്ടാവുക. And this type of ROMs are known as masked ROM and its cost is inexpensive. The next one is programmable read-only memory. Here memory is read-only memory and it can be modified. Once we return uh, the data is written during the manufacturing time, or otherwise it can be entered by the user at once. That is modified only once by the user can modify, but only we can modify once. The user buys a blank PROM and he can enter the desired program using PROM program. So using a PROM programmer, we can enter the information into that blank PROM. Once we write that program, we can't modify that. So inside the PROM chip, there are small fuses which are burned open during programming. So during the programming, there are small fuses are there that will be burned, and it can be programmed only once. That is very important. That is PROM memory only programmed once and it is not erasable. This is an example of PROM memory. Say IC. And next type of memory is EEPROM, erasable and programmable read-only memory. This EEPROM can be erased by exposing it ultraviolet light for duration up to 40 minutes. This is an example of a EEPROM. So here there is a quartz is here. This is the quartz. In that quartz we are passing an ultraviolet light, then it displays the charges. So normal use this quartz lid is sealed with a sticker. If we want to erase this charge, we pass the ultraviolet light is passed through the quartz crystal window. Here, EEPROM eraser achieves this function. During the program, a electrical charge is trapped in an insulated gate region. The charge is retained for more than 10 years because charge has no leakage path. So once we charge, it will be retained for more than 10 years. Then if we want to erase that charge, we are passing ultraviolet light through that quartz. The next one is EEPROM, electrically erasable and programmable read-only memory. Here it is programmed and erased electrically. So it can be erased and reprogrammed about 10,000 times, and both erasing and programming take about 4 to 10 milliseconds. So we can using this EEPROM, electrically erasable and programmable. So it can be programmable and also erasable by electrically. And EEPROM, any location can be selectively erased and programmed. So we can select some portion, and if we want to delete or delete that portion, then we can select that portion and erase that portion. And if we want to reprogram that portion, then that also possible in EEPROM. So this EEPROM can be erased one byte at a time. So at a time we can erase one byte rather than erasing the entire chip. So the process of reprogramming is flexible, but it is slow. So that's all about ROM and different types of ROM. Thank you.